Hello everyone. Today hands-on lab is all about control. While dynamic routing protocols are powerful, static route gives an administrator precise control over the path of the network traffic. In this session on Packet Tracer, we will configure static routes on Cisco routers to ensure connectivity between remote networks. Again, we will focus on the IP route command, verify paths with show IP route, and troubleshoot any dead ends. So let's get started. Having said that, let's continue to set up our network topology. We'll have our router, another router, a switch, another switch, a laptop, a PC, a server, and a laptop is our end devices. So I'll connect them automatically to save on time. And then write down the network addresses that we're gonna use in this topology. The second network, and the final one, that will be 192.168.12.0. Done. So we're going to assign IP addresses to our end devices. For the laptop, we'll use 192.168.10.2. Then we have to assign a default gateway to be able to have access to the router. We do the same to our PC. And also to the end devices in our last local area network. Now that we are done with the assigning of static IP addresses, we'll have to configure IP address to the interface to our routers. You type enable mode to get to privilege mode, and then configure terminal to get to global configuration mode. And we are going to begin with the interface G001 and assign a similar IP address that we had assigned as default gateway to the end devices in our first local area network. Then the subnet mask, and use the no shut down command or no shut to turn it on. And the other interface, that is G000, we issue an IP address of 10.10.10.1, then the subnet mask. You use the command no shut, even though it won't turn on until we do the same on the other router. enable, and then you use configure terminal. You type in configure terminal. So we are going to begin with the interface G000 and assign an IP address 10.10.10.2, and the subnet mask 255.255.255.0. And when we use the no shot command, now it will turn green, and as you can see. And the final interface, that is interface G001, which is also acting as the default gateway of the last local area network. We'll use 192.168.12.1, and then we add the subnet mask. We write down the subnet mask, 255.255.255.0, and then we type in the command no shutdown to power it on. So we're going to test the connectivity. Can they really send a data packet from one end to the other? And I want you to be very careful. You should watch on the bottom right side to check on the status. Okay, that is within the same local area network, and you can see it is successful. And to the router, yes, it is still showing successful, but to the other router, if we try to send to the other router, it fails. You can see it is failed. That is because the first router do not have the routing information about the other router. You can see if you're trying to send any packet to the last end devices, we're not receiving. So we are going to configure a static route on the first router so that it can have the idea that there is another remote network, and update it within its routing table. And the command is IP route. Then you include the IP address of the destination network, and then the subnet mask, and then you include the IP address of the next hop, which in layman's language means the IP address to the interface of the next router. You do the same to the second router. You type IP route, then the network address of the destination end devices, its subnet mask, and the IP address of the next hop. Done. So we can save our configuration using do write command. So we can go ahead and test the connectivity. It's successful. On first instance it may fail, but if you repeat the same, you can see now it is successful. Try again. You can try again, then for it to update the routing table. You can see now it's successful. Now let's use the simulation. Now I'll try to use the ping. I'll try to use the ping to confirm the connectivity. This is another method you can use to actually test whether your devices are actually communicating. And you can see that data packets are being sent, and 4 sent, 4 received, 0 loss. So it means that our network is fully functional. And to this far, we have come to a conclusion, and thank you for watching.